Hello and welcome back to stream number 80 of this series where I am programming an NES game live on Twitch from scratch. Happy New Year. It is January 7th and we are getting started here on our streaming for the new year. Got a lot to do. I'm thinking this is going to be pretty long recording. And so what I'm thinking I'm going to do is split this up and make a couple recording posts just so that it's a little bit easier to digest. Hey Vashtarek, thanks for joining the live stream. Hopefully you can hear me okay. This is a new mic setup too for the new year. I think I'm going to be keeping it. We'll see. We'll see what people think of it. If it's working better than the old one. It's not right in my face like the other one was. I had the old one kind of set up off to the side of the camera so you couldn't see it, but it got in the way of me seeing things on the screen because everything is kind of up close. So yeah, let's get started. Or rather, let's continue with where we were. So where we were last time was we were changing the configuration of how the asset tool works. We were trying to make it so that it was storing the image data for the sprite as a series of tiles rather than one large image buffer. And the reason that I had changed that was because what I want to be able to do in the configuration, none of these are what I want. I'm going to close Twitter so I don't get distracted. What I want to do now is I want to change it so that with a file like the ship that we were looking at here just a moment ago, we can split up the image content into 3 tiles that can be positioned based on offsets rather than just having a large image buffer. Which I'm going to the wrong folders here. That's how you know it's been a while since we've done this here. So yeah, I wanted to be broken up into tiles rather than just having one large image buffer. And we had spent the better part of last stream kind of working on that. And the idea is that we want to take this new ship sprite that we've got here, and instead of dividing it up into 4 pieces, divide it up into 3 pieces, and use this config file to do that for us so that we can be efficient with our sprite usage and also handle our palette options a little bit better. I'm actually wondering, now that I'm looking at this, if I want to just incorporate this into this and just say, you know, palette 0 since I'm going to the trouble of providing these parameters, maybe it's better to have it defined like that. That shouldn't have changed anything because I'm not looking for the palette parameter. So if I go back and take this and re-export it, what I should see when I load it is it should be exactly the same. Yep. Okay. So now we start getting into the little bit of the tricky part where we are selectively choosing parts of the image rather than choosing the entire image and turning that into individual tiles. So let's do that. And bear in mind that when we make that change, it's going to, in the asset tool, it's going to load the tiles wrong. What I expect to see after we make this change is we will see this part at the top of the ship and then these 2 bottom tiles. Okay, so let's make that change, and then we can fix that once we get that working. All right, so let's look back at how exactly we're doing that. So right now, we are okay. So right now we're not actually loading that sprite metadata for the offset of the image for the tiles. So we need to start storing that. So let's do that, and then we can actually selectively choose that portion of the image, and then store that off into the sprite file. So let's do that here. Okay, so it's called sprite position, so we just call our helper function to get our the beginning of that property, and then go to the next location and actually, before we do that, we need to know how many. So we're going to create something called number of tiles, which will tell us how many tiles we're using here. All right, so and that's just our tokens size. All right, so obviously we don't have number of tiles anywhere. Let's add that. We'll go back. Is there a shortcut? There is a shortcut. All right. So now we have a number of tiles, and when we're done with that, sort of, let's see. So now what we need to do is store off our offsets as vectors, and we're not going to deal with the palettes yet, just to avoid having to deal with that for now. All right, so put that right there. And the same thing. So we're gonna allocate size of 2B based on the, dear Lord, what am I doing today? It's just that kind of day, you know. Went back to work today after being on vacation and just getting back from MagFest, which was a lot of fun. Met a lot of cool people there. It was cool, nice to actually put some faces and voices to the people I've been talking to online. So yeah, it was a fun time. All right, and we'll set that. And then we actually will probably want to do, no, that's fine. Okay, so now the only other thing, I'm not sure I like that name. really tile positions. Okay. So we have our tile positions now. What's the problem with this? Oh. Now it's early in the stream, I'm already making silly mistakes. This doesn't bode well for later. Alright, so we've got that, and now we're going to do essentially the same kind of thing as we've got here. We're going to just check if the object that we're dealing with is an actual object, and then if it isn't, we will return and add yet another to do here, and then we say okay. Alright, so we get our property value as uint, and we're just grabbing our x and y position, right? Seems simple enough. And then we want to scoot over to the next object in our list of objects. And then the only thing, actually, this is this should just be like this, because we're not doing Actually, I wonder about this. Is this a bug? Number of bounding boxes times 2. This might be a bug now, because we had changed. The bounding boxes were originally... I gotta think about this for a second. I don't remember... No, I guess it's... Oh, you know what it is? No, sorry. Same kind of code. It's, again, been a while since we looked at this. This is our, we're skipping over the elements in that tokens list, which is a flat list of all the JavaScript object notation stuff. So that's why we're doing that with the times 2 plus 1. Alright, so we've got that, and let's just see if that actually reads in what we expect it to. The only problem is I have this open, and we're going to have to run it through conversion and not just load it. So let's switch over the command line to this. Okay. What happened? Sprite position. Sprite position. Am I not getting an index for it? Was working. This was working before. Let's see. Oh. All right, so let's add this also. We want to make sure that we're getting an array. And calling this? Collision points. Index is 0. Take a look at this. Is there something wrong with the okay. Oh, does it not like the comments? Is that why? I guess it doesn't like the comments. Okay. I didn't realize that was a problem. I would have thought it would have just ignored it, but I guess the JavaScript portion of the JavaScript object notation only goes so far. Alright, so that's working now. So let's see, so number of tiles is 3, which is what we would expect, and then we allocate our positions, and then we are going to loop, and it is an object. We're going to get our X position, and our Y position will hopefully remain 0. So and that's what we have in our JavaScript, which is good. Okay. Zero 8, yep. And then 8 8. All right, cool. So that's all looking good. Not at a point where we want to write that out or use that yet. So let's get rid of that breakpoint and that breakpoint, because now we know that we're loading the descriptor properly. So now let's go to create sprite, where we are writing all of this out, and we have to do a few things. First, we have to do the same thing we were doing with some of these other bits here. We are creating pointers that will hold our data, because we don't want to write that out into the file. We just want that pointer to be null, since it doesn't actually mean anything outside of runtime in this instance. Okay, so that's tile positions stored off, and then we say new sprite tile positions equals null. Oops, let's go back to that. And then after all of this is done, we've got to go back to the 6502 stuff and make sure that we didn't break that. Alright, so now here's the real trick, right? Like right now, what we're doing is we're looping through the image buffer and we're writing all of the tiles, right? We're writing every single one of them. But instead, now we have to write just the ones that are part of the tile positions. Size of vector 2b times new sprite dot tile positions. Oh, tile count. Number of tiles? Yeah, number of tiles, right. Alright, so we've got that being written out, and the only thing we need to change here now is we need to modify this, and instead of just doing it at 0 through the entire image height and width, we want to loop through and do each tile and just do the 8x8. So we want to do a loop of I0 to new sprite, new sprite, number of tiles, and then for each individual one, we're going to take tile positions I dot y, and we're going to do that just like that. And same thing here, we're going to say new sprite tile positions ix. We're going to add x to this because, again, now we're not just writing the whole large image buffer as tiles, we are writing individual pieces as tiles, and so we should hit this 3 times. So let's look at what this looks like here. So for the first one, we have y, and we have x, we have I. Oh, right. Helps if you use the pointer that's actually valid. All right, let's try that again. Alright, so x is 4 and y is 0, and so now we should just basically end up copying actually, let me think about this. So we actually only need to do, well, this should break out of that loop because we're just doing the one. Okay, that works. And then the same thing here for 0, 8. So that should have written the 3 tiles. So let's take a look at that here. Alright, so far the data looks okay, and we added to it the sprite tile positions, which we wrote out as, let's see, 400888. Okay, so that all got added. Now we've got to load that. So we've got the sprite load here. Let's actually fix this to read the data properly. So now instead of doing just the width and height, we want to do the sprite number of tiles times 64, which we can just do that. right? Because each one is 64 bytes, and however many of these tiles we have, we've got 64 bytes worth. So that gives us that, and then after we add our semicolon, we allocate it, and then we read in our data for the images, and that will give us the correct number of tiles. And then let's see, we read our bounding boxes and our collision points, and then we want to read in our tile positions. So let's do that. Size of the vector 2b times sprite tile number of tiles, and that's that, and then mem set that. No, not size of size, just the size, thanks. And then that gives us that. Alright, so that should have loaded it properly. Okay, good. And then I expect that this is not going to draw the thing properly, but let's take a look at what happens when we load it. What we should see is what I said before, which is we should see the tiles all kind of squished together, which is fine because we can fix that. If we get something else, then okay, so we sort of got it. We got the first tile, which is what I wanted to see, and then we got some other stuff. I wonder if it's because it's creating the image incorrectly. Let's see, so we have our image data. This is reading the raw image data. That's just a raw. Okay, so if we go to load sprite, oh, you know what? We have a draw sprite. Yeah, so draw sprite should be looking at now number of tiles times 64. That's 32, that's 64, and then alright, so now, so what it's doing right now is it's just looping through our height and width of the sprite and copying the raw data into this image object or struct. And instead, what we need to do is we need to change it so that we are loading the tiles into the appropriate positions based on the tile positions array. So what we want to do is we want to keep this around because of my tendency to forget how this all kind of lays out, but we want to say, let's see, I is less than sprite, number of tiles, and then that gives us our iterator for the actual position. So we still want this because this is going to be the same, it's just instead of using X and Y like that, we want to do sprite. Here, we'll come on. Just give us our temp there and alias that into the temp pointer, and then That, I think that's, actually no, you know what? The tile offset. No, actually that's not even right anymore. It's actually simpler than that. Okay. So, simpler than that because we have temp, and that's our X and Y position that we're drawing into. I'm gonna put some WD-40 on this chair and get the squeaky noise out of it. Alright, so that's our X and Y position that we want to render into. Now, the actual data, though, is just these 64 bytes. So there's no need to do any sort of... oh, I got rid of temp. Oh, whatever, I can bring temp back that way. So temp was just... the only thing I have to do here is this offset, and it's not just I, it's actually, or J, it's I times 64 plus J, because we want to skip the number of tiles we've already processed, plus the current byte that we are in, or sorry, the current tile that we're in, and this becomes... the same thing. What is this? Get out of here. Okay. I think that will draw it properly now. Nope. Alright, so iterate over number of tiles, then iterate over 64 bytes. Get the tile positions. Let's take a look at what we're getting here. Make sure we're getting that properly. So temp. Okay, so that's our first problem. Why did it not read that correctly? Let's take a look. Probably add the same thing here. Not that it matters a whole lot, since this is mostly just a one-run sort of deal, but it doesn't hurt in case we end up calling this a bunch of times for some other process that we end up doing down the road. Alright, so step into there. We're going to open the file. We're going to read it. Alright, we have our height and width. Our number of tiles is 3. So we've allocated a size of, 192. Oh, you know what? No, that's okay, because the image data still comes in there. So if we look at image data, okay, so that's the first problem. Why? Oh, it didn't actually read that yet. Okay, that looks good. Right, that at least looks like a reasonable set of data. Okay, so We've set that there. Read our collision points. We have our size, the number of tiles. That's 6. That's this. Okay. We allocate the tile positions, and then we mem set it, and then, oh, I went to the trouble of setting up the memory and clearing it, and then I didn't actually read it. Which doesn't work. Alright, so that's why that's not working, so that's good to know. Alright, let's see what's going on here now. Current sprite, tile positions 0. Saying 1 1, but that's not right. 3 2 3 0. Or these are collision points. Did I mess up the arrangement of the data? Take a look at this after the read occurs and see what's going on. How many collision points does it have? Okay, so this is right. This should be actually using the number of collision points and not hard coding it like it was. Sprite. Well, that seems less bad, but still not good. 130202. Number of collision points. 3 collision points, which meant that it should have read in. Let's take a look at. Sprite collision points. Okay, that's what happened. Number of bounding boxes 1. 1 bounding box, which is that set right? One. That's not right either. 3 3. All right. It's like we're reading too far past. I wonder if, let me re-export this just in case I didn't allow it to completely export. help you think of a simple game idea for the competition. What defines simple? All right, let me reopen this file and see what's going on. This does not have what I expected. Quotable in less than a month. I don't know. Do a clone of another game and give it your twist, and there you go. You've got a competition entry. Oh, okay. So this is part of the problem here. We're iterating through the number of tiles, but then we're writing out the full image size. So this should be what is it called? New sprite? Tile count, number of tiles times 64. Okay. Let's try that again. That should change the file size. I mean, the hard part of the game, if you already know how to program on the NES, the hard part of any game really is to make something that's actually a game that's fun to play. At least from my experience, all this stuff is just kind of tech stuff that gets in the way of you doing that. And then once you have that done and working, you go on to the hard part of figuring out how you're going to make a game and how you're going to make it in the time constraints that you have, and the art constraints, and the system constraints. Skyrim for NES. Why not World of Warcraft for the NES? Why stop there? Just do a MMORPG. That's what it seems like everybody wants to make as their first project is an MMO or something similarly insane, and then they don't accomplish anything. I think I referenced it some other time. There's a couple of cool videos on like game genres you shouldn't choose for your first projects, and RPGs is on that list. Why is this not working? Is this writing to a different location than I expect? New ship. New ship, that's a whole different other file. I mean, one of the things that everybody always recommends is like a Pong clone or Asteroids clone or something along those lines. I know it's not as interesting as doing a large game. You already did the Pong clone thing. Alright, well, you do something cool with graphics and your Pong thing, use raster effects on the NES. That's tough to do. We could do it quickly if you've already got Pong, and then you could do like psychedelic Pong, or I don't know. I mean, if you've looked at any of the previous competition entries, they kind of vary in terms of what people are doing with them. I think this is good. I think now I'm just messing up the draw. Let's see. Let's see if I can fix this. Alright, so alright, now at least the X and Y position is correct. And the sprite width is that, and so our image should be 16 by 16. It is. So that's okay. This is okay. That's all right. And then, oh. I see what I did wrong. I see. Okay. So really what I want to do is then I want to kind of iterate over the X and Y. Let me think about this. So, because before we were doing the, we were reconstructing the image using the tile offset, and then our X and Y was unchanged. I mean, we could, maybe we go back to doing it that way. Well, the problem is, though, that the tile position is really what dictates where it draws, and then it's just kind of... You know, this is actually not necessary. What we can do is we can say, we have this outer loop, and this is that. Oops, this is that. And then we have our I had an idea for a competition entry, but I don't know that I'm going to get around to doing it just because hardly have enough time to work on this realistically. And then I have the 0 pages stuff I need to finish up, and then I don't have much free time beyond that, so it's kind of one of those things where even though the concept is pretty simple, sitting down and doing it may not actually happen. Let me look at this. So it's the offset of the tile that we're in, plus our X plus Y times the width of the tile data. Excuse me, that looks right, and this is just the temp X plus temp Y. And then what I want to do, I really want to, here's what we'll do. We're going to copy this, and then is it going to be smart enough to know how to do this? So let's temp. Yeah, I didn't think so. Okay. I don't always remember the rules of how this kind of deref stuff works here, so... Oh, wait a minute. Is it because... No, okay. I thought for a second I used the wrong data type, and that's why it was complaining, but it's not that at all. It just didn't work. Alright, so that gives us that, and then I'm just gonna end. Alright. Maybe I can adapt an old DS homebrew game I made forever ago. I mean, yeah, again, it's like if you've got the design done, that's really the hard part. It's more of an issue of then trying to just implement something quickly. What don't you like, Windows? What? What? I don't even understand. Why is this triggering a breakpoint there? What happened? Seriously? That's weird. So it was actually compiling with this here? What was it? I'm confused. There was some stray character there that it was still compiling with. I don't know. I don't know what that was all about. That was odd. All right. That's bizarre. So it doesn't like the window registration with the change I made. Am I overflowing the bounds of... Am I overflowing the bounds? I guess I could be, even though I'm not sure how. But let's look. Temp 40, okay. Oh. It's because the X value is getting incremented. That's just a dumb mistake. All right. We gotta reset that after each loop. In fact, no, we can do it. Doesn't matter. All right. So yes, it was a buffer overflow. It's weird that it kind of caused that problem. There we go. All right, so we've got that part, and then that is wrong, but that's close. That's close. All right, let's see what the issue is. So what we're seeing is it is drawing this part here. Is it that I defined the metadata wrong? X is 0, Y is 8, and then X is 8 and Y is 8. That all looks good. real question is it because the tile data is wrong, or because the draw logic is wrong? Let's take a look at this for a second. So, sprite image gets us, how many bytes is this across? So it's by any chance 64 bytes to make it easy. How many bytes are you? Anyone? Columns. 64 here. That's 64 columns. All right, let's do 32 so it actually fits. So that's 62. So that's 64 here. Okay, so it's the tile data because you can see here that that's all 0. And then this has some actual tile data in it here, and it's not 0. So for some reason, for the first tile we're good, for the second tile we're not, and for the third tile we are still good. So let's fix some tile data. So now the question is, why is this wrong? If we start at y is 0 and x is 4, that worked fine. And then we add 8 and we're done, and then I iterates to the next tile. Oh, I've got to stop this here. Let me let's go back to the export. All right, so if we look at tile positions I, first one is 4, 0, and that one was fine. Now x is 0 and y is 8. Image width divide by 3, or divide by 8, I mean, and then by, so tile buffer pointer. So that's our tile data, and we're taking our x position and our y position. The x is getting divided by 8, the y is getting divided by 8, and then multiplied by, oh, and then multiplied by the width to give us our offset by number of tiles. And let me think about this for a second here. Yeah, okay, and that's fine. Oh, wait a minute. That isn't fine. That's not fine because it's no longer just dealing. It's fine to use the width here because for the source we're still using the 16 by 16. For this, what we should be using is I times 64, or no, y times, let's see, y, this is the width, this just becomes times 8, and it's times 8 because the destination always has widths of 8 now. Because it's been reduced to 8x8 tiles that don't have anything to do with the width and height. I think that'll fix it. Alright, so that re-exported it. And well, now it just broke it even more. Okay, let's go back here for a second. So our x is divided by 8 because that's just an overall x position to the destination. Oh, is this whole thing wrong? That might be the problem, is that this whole... because we're just doing the write out directly of the tiles without it being related to the full image buffer. This is really just tile buffer times I by 64, and then we just iterate. The destination increments by 8 each time. Okay, let's try that. Now, you may be looking at this and going, wow, he's going through a lot of stuff here to work on a simple shmup game. And it is a little bit, I admit, over-engineering for that specific project, but I'm also partially building a tool set, hey, there it is, that I hope to use for all my future games on the NES. And so the process that I'm taking here is with the idea of, at the very least, having a sort of comprehensive tool set that will allow me to reuse the basis of this for future projects. So, all right, we've got our 3 tiles. They're properly drawn now. I assume. Okay, cool. So that is still working correctly. It's not broken. But the only thing that is not correct is that these empty spots are not index 0. Which they should be. I'm surprised they're not, but at the same point, I guess let's see if we can do this. So memset pix with and then this should be size of char times 60, no, times image width times image height. And then what's the issue here? NES palette. Oh, because it's not. Boo. Let's change this indexed. It's because it's using the T pixel and not the not just a raw value. Right, fine. Let's just do a loop here. And initialize this. Oh, wait. Sprite palette 0, 0. Let's see if that. Yeah, okay, cool. So that gives us now a consistent background color that if we change, we are getting. All right, so this obviously still has some issues with the background color not being the correct color and swapping some things, but let's do this. So there we go. I like it. Cool. That actually worked the way that I wanted. And then does that? It does. Okay. Nice. And I assume that if I save that and reload it, it will still work. That apparently was too strong an assumption to make. Oops. Okay, so let's see here. Save sprite. Why are you doing this, save sprite? Because you are different than create sprite. Damn it. And you're just writing this out directly, which is wrong. And then you're not writing number of tiles. Oh, damn it, no. Tile positions is that. Vector 2b, temp tiles is equal to sprite, tile positions, okay, and then just restore that back, please. Try again. Genius. Alright, so that's that. We've got our this there. Alright, so although the image stuff is going to be wrong. Alright, that's fine. That's more an issue with the way that this save occurred. So now what we have to do, we may have to, I may want to pull this out of create sprite. Oh, and this is wrong too. This is size of, let's see, it is new sprite, number of tiles times 64. And then tile buffer gets allocated based on that. But let's do this. Let's, for now, let me copy this out and save sprite. And this is sprite, number of tiles, tile positions I, this is temp tiles. And then and the sprite image is already indexed. And this is sprite width. Sprite width. I think I'll need to, probably going to end up just extracting this method out, or this code out to an independent method that can be called by both create and save, but for now I just want to prove that if I change this it works correctly after saving the sprite. I'm glad I checked that. Alright, so that now exports, let's see, so that's the right of sprite, and then it writes the image data, and then the bounding box, and the collision points, and the number of tile, excuse me, the tile positions. Alright, let's try re-exporting it, and loading it, and then saving it. Why did that not work this time? Oh, I know. I know we made a change. I made a change to something here about the size of the buffer. It's possible that broke it, although I'm surprised that it would have, unless I sized it incorrectly. Let's see. Number of tiles, that's that buffer size. Destination is tile buffer, and I times 64. Shouldn't need any. Oh, whoa. That's not even close. It's not shift 64, it's shift 6. Alright, so it wasn't allocating, or maybe it was allocating the memory, but looks like it probably wasn't doing it, and that's not going to work. Okay. Even if it was allocating it, the problem was that that was way too much memory to allocate. Alright, save that. And now let's reload it. Damn you. Alright, oh, you know what? I'm probably doing the same, I probably have the same bug now. This is why you gotta refactor your code when you realize you've got something that you have copied and pasted and don't want to have to fix in multiple places. Let's do it. Let's do it over here. So we want to take the, let's see, we need the sprite file handle. So file handle file, And then what else do we need? We need, what is this, an unsigned int, u8, come on, that's supposed to be an 8, number of tiles, and then vector to be tile positions, and then let's see, what else do we need? Our source width, and then we want our source image, and that should be enough, I think. We'll find out in a second. So what we're going to do is we're going to change this to just call, what is this? This is create sprite. So we're going to change this to call write sprite image data. And we have our file, and we have new sprite, number of tiles, and we have our, let's see, new sprite, tile positions, and the image width, and image indexed, which is our source. So what is it complaining about? Unsigned char is okay, so make that unsigned. And then what's the problem with my file handle? Oh, it's an int. Right, because it's a file handle and not a text file handle. Okay. So we got that now. Let's move this all out. And then this will be broken, but that's okay. So we got number of tiles. Number of tiles, tile positions, let's see, source image, and then this is our source width. Okay, so that's that, and then this is number of tiles, and we've written it, and we've freed it, and okay. So now let's change the other place where we have that to just call this function, which is what I should have done before, because we've got that same bug. So write sprite image data file. Sprite number of tiles, sprite tile positions, sprite width, and sprite image. And this is, just cast it. Doesn't actually matter in this case, and now we will get rid of this garbage there. Okay. Write sprite image data. Oh, it's literally right here. I'll just move it. Okay. Destination tile position is null. Why? Oh, because, right. Okay, so that should have exported it correctly. Switch that and save. I don't like the looks of that. Alright, so it crashed. Why did it crash? Okay. Tile positions is null. Did I make the same mistake? Yep, I sure did. Okay. I'm going to have to re-export it again because it corrupted the file. Now what? Now why are you crashing? Destination, source, source image. Oh, I did the same. Okay, I did the same thing, just with now the image buffer. What is this called? It's called temp image. Okay, so that ran. And then swap that, save. Hey, it didn't crash. Okay. Not quite. Okay, so what's the problem? So the problem... Oh. Actually, the issue... I wonder... Maybe I didn't need to do that. Because thinking about this, the image data, if we were pulling it out of the image we were drawing, we'd need to do this. I wonder if it was just a matter of I was writing the wrong amount of data. Let's see. Size of char times this would be sprite number of tiles times 64. And that would be it. Temp image. What is this? Okay. It's not still running, right? Not anymore. Okay, let's re-export again. You know, I could probably save myself some effort here by going into this and running this every time and just doing the debug of the load from here. Since I'm going to the trouble of having a command line version, or a command line driven tool. There we go. That was what the problem was. Much better. Alright, so now we are dealing with that properly. Now we have to deal with the export. So let's do that now. So right now we are exporting our sprite data based on the size of the sprite, and then we're doing the generating the code to draw the sprite based on the size, which is no longer correct. So we should be able to change this now to export just the raw tiles we need, and they are independent of actual screen position, and then our tile positions will dictate where they're drawn and how many tiles we draw, which is cool. That's what we want. So let's see here. Alright, so we've got our code. Iterate through all the sprites. And take the X and Y from here. Let's see, where is that getting set? That's getting set. We're just iterating through. X is greater than 0, then do the addition. Otherwise do that. And total sprites is based on the number of, it's based on the width and the height, right? Which is no longer correct. So where's that calculated? Total sprites is, if it's animated, do that. Otherwise, we're taking the width and height and dividing by 64. That's no longer correct. That's also true with this guy. Wow, you know, I didn't even think about the animated. Well, actually, that would be the same, because we would be pulling. It would have to be consistent across every sprite where we're pulling from. So we just say, regardless, the total number of sprites is number of tiles. Boom. Alright, so then our width is, the animation frames is width divided by frame width, which is fine. And then the only problem we have left is that we're using X and Y and just iterating through it directly, and what we want to do is we want to, let's see, so this works because this currently is looking at, oh, okay, no, this is good. So if y and x are not 0, then it does the add to the y position or to the x position. So that's good. So what we want to do is we want to say x is equal to current sprite tile positions total sprites of x, not total sprites, sorry, j, because we want to iterate through that, and the y is the y, and that should fix that. Now we have to re-export, or we have to convert all the sprites back, and this doesn't apply, this won't work for, all right, let's take a look at our assets here. So now we have the situation where we don't have, all right, we don't need these ship bottom and top anymore. And then, okay. The other thing we don't have correct is when we do our export, convert sprite to JSON. So a couple of things. When we create our sprite, if the tile count is 0, because we didn't include the sprite metadata, then we need to figure out how many sprites there are. So, okay. So before, what we were doing was we were iterating through. Here, I'm going to create a break in the recording here for a second, and then I'll explain what we were doing before.